In this video, we'll be looking at a combination of graph transformations. I always introduce the transformation of graphs with these. If you see a change inside the bracket or inside the function, it will affect the input. What's the input? That means the x values, and it will affect them inversely. If you see a change outside the bracket, it will affect the output, that's y value, ordinarily. So notice I, O. This should help you remember everything. Now, what do we mean by change inside the bracket? For example, f of x plus a. The value of a is added inside the bracket. So it will shift the graph in x direction by negative value of a. So that's where the word inversely means the opposite effect. Where you see a plus a inside the bracket, actually the graph will move to the left. Let's go back and look at the translation in y direction. The a here is plus, this plus a is outside of the function or outside the bracket. Therefore, it will affect the output of the function, that's y values. So the changes in y direction, and it's happening ordinarily. Plus a means that we will add a to y values, or rather the graph will translate upwards. Now let's look at some stretches and reflections. First of all, let's look at the reflection. The negative sign is inside the bracket here. Therefore, x values are affected. X values are flipped in the y-axis. Where the negative sign is outside of the function, that's y values affected. So the y values will change or be flipped in the x-axis. When a is a multiplicative constant inside the function, that is a stretch factor, and actually the graph will be stretched by a factor of 1 over a, that's inversely. And when a is outside of the bracket or function, the stretch factor will occur ordinarily, that is, it will be stretched in y direction by a factor of a. So let's look at this example, and this should consolidate what I just said. So we've been given a graph of this red curve here. This is the original function y, and we've been asked to sketch that with for the graph of 2 times f of x minus 1. Now you see both of these changes are outside of the function, so we will see changes in y directions only. The factor of 2 outside of the function will stretch the graph by a factor of 2 upwards and downwards. So this value of 6, 4, how will it change? The value of 6 is the x value, so 6 will not change. But we will have 4, which is the y value, doubled. So this 6 and 4 will become 4 double of 4, it will be 8. But after that, we'll have to subtract 1 as well. So 8 minus 1 will be 7. This will be the new coordinate of b. I'm going to call it b dash. Value of the coordinates of a is 2 minus 1. The value of 2 doesn't change because that's the x value, but the y value is negative 1. We will double it and take away 1. Doubling minus 1 is minus 2. Minus 2 minus another 1 will make it minus 3. So the a will be translated or transformed to 2, minus 3. Let's look at the transform graph. So if vertical stretch with a factor of 2 and a translation downwards. So let me wipe off my writing so that you see clearly. As we said, changes are outside of the function, so the y values are affected. Let's look at another example. Question. We've been asked to transform the same graph, but this time we'll have a different transformation. This time the change is +2 inside the function and a +2 outside of the function. The +2 inside of the function really shifts the y-axis forward, but with naked eye we will see the graph shifted to the left by 2 units. Therefore 6 will become a 4. That is, the x-value will be changed by the opposite or inverse of a +2, which is -2. And this 2 will become 0 because 2 minus 2 is 0. Now let's look at the y-value. Y-value will be added by 2, so the 4 will become a 6. And this -1, when you add 2 to it, becomes a +1. So let's look at the transform graph. It's a horizontal translation of 2 units to the left, and as we said, we will get 4 and 4. That is just the horizontal translation, and once we apply the vertical translation, we will get to what we said, 4, 6 and 0, 1. Okay, notice I did both transformations at once, but the slide had to do one at a time. This is still example 2. Okay, so let's look at the next example here. Here, we've been asked to sketch the graph for a function that's changed by a factor of a quarter outside of the function and 2 multiplied inside the function. So the stretch factor for x actually will be half. The 6 will be half to 3. 4 will be divided by a quarter, so it will turn into 1. So that's the coordinates of B, and coordinates of A, once again, the x value will be halved, so become a 1, and the y value will be times by a quarter ordinarily. So the new values of A will be 1, a negative quarter, and B, new values of B, new coordinates of B will be 3, 1. So let's see. Okay, as I said, the graph will look something like so. So how would we know where this origin is going to turn out to be? Well, multiplying 0 by 0 doesn't change the x value, and multiplying 0 by half doesn't change the x value. Multiplying y value 0 by a quarter doesn't change it. So the origin will stay at the origin. So let's look at the next example. In this example, there is a negative sign outside of the function, so that's a reflection of y values outside of the bracket affects the output, that means the y values ordinarily, which will be reflected. So and also, let's deal with the y values then. When they are reflected, the negative one will be a +1, so that will reflect up in the x-axis, and y value will change to -4, so that will means that the graph, the new y value will be down here. Now let's consider the x values. X values will be added by a unit of 1, because the y-axis will shift to the left by 1 unit. What we see with our naked eye is that the graph will actually move to the right by 1 unit. So this 6 will go to 7, and this 2 will go to the 3. So we have 3, 1 and 7, -4 for value of for coordinates of A and B. So let's see that the x coordinates will actually increase, and y values will be multiplied by a negative one. So as I said, these are the new values, and let me wipe up my writing so you'll see them correct and accurate. Okay? another example. We've been told that the function will represent the logarithm of x, where x is always positive. We've been asked to sketch the transformed graph of 2 times f of x minus 30. So that means for part A, y will be 2 times logarithm of x, and after the function we'll have a subtraction of 3. Both changes will affect the y values in part A because there is no change inside of the bracket. So we will stretch the graph by a factor of 2 in y direction. That is, positive values become more positive and negative values become more negative. And then we will translate the graph downwards by 3 units because of the minus 3. This is the effect of multiplying by a factor of 2. Notice it's hard to see exactly how, how the graph is stretched because it's stretched in y direction and there is no coordinates that we've been told. The, actually, this stretch leaves the point 1 as where it is. The x values don't change. Now we will translate the graph downwards by 3 units. So you might be tempted to think that this x value changed, but we're not sure exactly what the value of this new intercept is. We're going to calculate it on the next slide. Notice that we are saying the asymptote is x equals to 0, that is y-axis. Yes, the vertical asymptote y-axis is equal to x equals to 0, and that remains unchanged because we are stretching by by a factor of 2 in y direction. The asymptote doesn't move. The asymptote would would be shifted if the change was inside of the bracket. So let's calculate the new intercept. The new intercept is where y value is 0. So we can substitute this y, replace it with a 0 and solve for x. So that's what we are going to do. We add 3 to both sides, we divide by 2, and we take exponential of both sides. We will have x equals to e to the power of 1.5, which if you put it in your calculator will give you 4.48. So that's the x coordinate on the graph, or rather the x-intercept of the graph. So we've answered part A, and we are going to now consider part B. Signs are outside of the function. That means the y values will never be negative. The negative part of the graph, that is this part here, will reflect up in x-axis. But at the same time, we have a negative sign in front of the x. That means the x values will flip sides. So reflection in the y-axis is because of the negative sign inside of the function. So let's see how that's showing up. The log of negative x actually doesn't exist, but we are just considering the graph for that function. Then we are going to take the absolute sign, so that means that the part that's negative will reflect up. As I said, this part here will no longer exist and it will be reflected only up. We'll only see its reflection above the x-axis. I hope you found that helpful. In the next part of the course, we will consider graph transformations in more detail.